Let's talk about OSI. Lots of O's, S's, and I's. But if you've looked at it already, you've got OSI, ISO, and if you really do the right abbreviations of the order of the letter of the words, it's iOS. So we've about combined the letters all kinds of directions you can, the O's, the S's, and the I's. OSI model is the model we're looking at, Open System Interconnect. All it is a model of how networking should work, and that if network systems use that approach, the network protocols, that then the different ones will be able to work together, which is why it's an open system interconnect to allow different protocols and systems to interconnect. It is a standard out there developed by the International Organization, the International Standardization Organization, or IOS. Okay? I think I got these in the right order right there for you. I got that backwards. It's the International Organization for Standardization, or ISO. Okay? It's ISO instead of iOS, because iOS sounds like a chemical symbol. And that's literally the reason that they do the letters for the organization opposite of what the words actually come out to be in English. The other problem is it is a French-Swiss named organization, and then they're translating into English. It is an international board for standards. So the ISO is an organization out there. You have seen ISO on stuff out there already as a standards organization. What have y'all seen ISO on before? Anybody know? For ISO 9000 for quality standards. Any of y'all seen that? Where an organization is been ISO certified as a quality organization. And you'll see a lot of organizations around with that. They've met the standards for that. Watch the tractor trailers when they go by with the markings on the truck, and you'll see the companies are marked as ISO accredited on. You'll also, when you drive by some manufacturing plants, you'll see them flying flags in front of the buildings too, saying that they are ISO certified. That they're ISO 9000 certified. 9000 just happens to be the standard number for quality standard. Okay? And with quality there, that's all you're saying on quality there about them being accredited on their quality is that they have got set procedures to do what they do, and that they follow those procedures. Is what quality is basically defined as. That we know how everything's built like. That they don't just go and build it and hope it comes out. So, ISO is out there. That is the International Standard Organization, and they set standards for all kinds of things in the world, so that we know what the rule is for what something really is. You've also got a U.S. Standards Board, which is called ANSI, the American National Standards Institute, which is in Gaithersburg, Maryland. It is a government agency, and it sets the standards for the U.S. for various items that we need a standard established on. They are the one that defines exactly what makes up an ounce of gold. They've got sitting in their headquarters spot there the ounce of gold of what is exactly an ounce of gold, and so on, and what represents all the different weights of what is that exactly. Somebody's got to have what the rule is for it, that we're all saying or whatever. What is an inch, a foot, etc. Y'all follow on that? So they just set standards on that. They also set standards on lots of other things, just like here of how should networks work, so they can work together. If they are OSI compliant, you can take different ones and put them together. And they should work together because they're working on the same approach. Although they've got their own specific way of doing all this stuff. So that we can take a Novell network, connect it to the internet, and manage to get the two to talk back and forth to each other, even though they're talking completely different protocols in the process. Or take other ones that are out there also. Today, we have settled pretty much on TCP/IP as the protocol suite that's being used across the line. And even like Novell and Apple have gone to those also, as opposed to they used to have their own set standard protocols for it. So if you moved a distance on that, got everything's moved towards the TCP/IP. So we've reached that point today, but you still got to look at this model to see how is stuff working. And then as we look at TCP/IP, you're going to find different protocols work at different levels. And how does the information actually travel from your computer when you hit that enter key to the fact it goes to that server and comes back and displays on your screen. And there's a whole process that goes through to get there. And that's what we're looking at with the OSI model and then the TCP/IP model for specifics of that set. They were developed both at the same time or are very close together, although they were separately developed. Okay? But they both date back to about 1980. Don't ask me the exact year on that one, but it's around 1980 both standards were developed. So the OSI model has been around for a good while, and that it is what everything goes on to make sure they can work together. There are 7 layers to the OSI model. They number from the bottom. So you're going to see, sometimes you may get asked about a layer number, or you may get asked about the layer name. And so you need to be aware of the fact a number from the bottom up.
Physical is 1.
Physical will be 1. So if somebody asks you about layer 4, they've gone up to the bottom. Layer 4 wouldn't be making a difference which way you number it from. If they ask you about layer 3, they're the third one from the bottom. Layer 4 happens to be the 4th one from the top or the 4th one from the bottom. So you may, sometimes you'll see things ask you about numbers and sometimes about names. So you need to know about. Do you need to know which order where do they number from? Are they going from the top or the bottom? Because y'all may have answered some surveys like I have a few times where they told you to rate something from 1 to 10 and failed to tell you whether 1 was good or 10 was good. And that you were supposed to figure out how you rated it as being good or bad, and they didn't bother to tell you which end was which one on the good or the bad. Sometimes they use 1 as good, and sometimes they use 10 as good. And then you sit there confused on, what am I doing here? So in this case, we're going to go from the bottom. And then we're going to have 7 layers. The bottom layer is a physical layer.